So, welcome, it's Carter Mac Valley again here, and we're going to jump right into it. Problem 4, largest palindrome product. A palindromic number reads the same both ways. The largest palindrome made from the product of two-digit numbers is 9009 is equal to 91 times 99. Find the largest palindrome made from the product of two n-digit numbers. Basically, this can be easily solved by using a two-dimensional loop, a for loop. This is my first guess to do this, but I admit I have spent a little time already thinking about this problem and how to solve it more efficiently than using a two-dimensional loop, which is a complexity of O(n) squared. And I'm going to have to try a little, or maybe even pause the recording because on fucking Clipchamp I only have 30 minutes of recording time. So let's see what I will come up with. So the basic idea is we'll start with, we can take 100 squared because 100 squared is equal to 10,000. It's not a palindrome. And also we want to probably make sure that if we look at these values 9009, 900, 6609, that the palindrome numbers are kind of in this range or maybe below. The main point is that the amount of digits in the result will have twice the amount of digits that is given here. So this result is 9000 is 4 digits and these are 2 digits. So this is my idea behind it. I can't right now, I haven't mathematically proved it. I don't have much time for that. But let's just wing it and see what happens. So we are going to start with oh, now this is better. Maybe we can also put in a second unexpected reserved word. As far as I can recall, this worked in Java, but I don't know if it works here. So let's just so my basic idea is now to make the limit to half of the next power of 10. So basically, if we have n equals 3, then we want to stop at 500 with the double loop. So we want to, I should be 500, and this has the reason. So when we take 101, for example, and multiply it by 999, we want the loop to go down each until 101. So it's 101 squared is the last calculation of the inner loop. And if we set I to, let's say, 999, then we have also already performed all the calculations for 101, so there is nothing to calculate anymore for 999. So this is my first idea behind it, but I'm not sure if it works. I'm going to have to try it out and see if it works. This is just intuition from my little mathematical head. And we are going to start j from the reverse. N plus 1 minus subtract. And ij will be larger and equal than math pow 10 n plus 1 and j plus plus. Now this looks shit. I'm going to have to... So this looks a little bit better. A little bit more readable. So we're going to... Also, we want to put a flag in here for to check if the number is still greater than 10 to the power of 2n. So basically we want this number, this result from the multiplications to be a little bit larger than 1000, or at least 1000. Now this might not always be the case, because if we add like 11 squared, we have a palindrome of 121. If we repeat this, this is a famous numeric phenomenon that if we square a sequence of digits of 1, then we get this beautiful palindrome 1 2 3 3 2 1 2 3 2 1. It kind of works like a pyramid. 1 2 3 4 3 2 1. This is useful, but this is not useful for getting the largest palindrome. So my beginning hypothesis, now that I look at this, is that it's going to be probably in this 900,000, 900 million range. And this is what I want to aim for, to just save a bit of computing time. So if I times j is smaller than math pow of 2n, then we can set the flag to false. Otherwise, that max palindrome equal to 0, max palindrome. So is I times j larger than max palindrome, and is I times j to string. Let me Google this shit. Number 2 string. To string. Okay, that works. To string. Let me just make this more readable. If yes, output I times j, otherwise output max palindrome. God, this looks annoyingly bad. Can't read this shit. No, what are you doing here? No, get away. No. Oh, great. For fuck's sake. Oh, come on. Now it works. Great. So, now we want to return max palindrome and see if it works. Sol.log. Well, that doesn't seem to be the case. So I'm going to pause the recording here a little and continue if I found the error. So as you can see here, I made a bit of debugging progress, a bit of cleaning up trash, and the loop already seems to work like I want it to. The big question to answer is the way I want it to the correct way, the optimal, the divine intellect way? And we'll have to see about that. Cut! So for whatever reason, which I couldn't find out right now, it's I guess the typical day in the life of a programmer. You don't know why it works and you don't know why it doesn't work. But this seems to do the job. So looping from, let's say, 101 to 999 and always keeping the J level maximally above the I level. So the highest it can do is a squaring, so it doesn't do too much computation. And this way it works. What I care about actually is if we can find a sort of a pattern of the palindrome numbers. So I'm going to do a temporary array here. Max palindrome 0 0. Then max palindrome so that's not the way I want it to be, but I want it to let's just simply copy this into an if before we solve this. I think that should do the job. Even though it looks kind of crap, but that doesn't do the job either. Well, great. Return our So I continued experimenting a little, and the problem I seem to run into that JavaScript doesn't have that much computing power. or doesn't compute that efficiently. So I started the I level from around 900. So the power of 10 to n minus the power of n of 10 from n minus 1. So it was 900, 9,000, 90,000, etc. and goes up all the way to 999, 9,999, and so forth. So this makes the whole code work for up to n equals 5, but if I edit it to n equals 6, then it gets a timeout. So this is of course not the way we want it to be, but this gives us some interesting results, which I may be going to check out in the future. But as far as that goes, we can hopefully run this and it works. So in case I find out something more efficient to work this out, find the largest palindrome of a number, then I'll make a video of it in the future. And up until then, thank you for watching. If you have any recommendations, anything you want to correct or refactor, well, maybe clean up that crap. But apart from that, if you have any ideas, feel free to leave a comment. And thank you very much for watching. Up until next time. Bye.